Hello, my name is Rupsa Jana, and I will be reflecting on my CaNCURE co-op experience. I have done my CaNCURE co-op in the Weissletter lab at Mass General Hospital. As a part of my project, I have been developing a multiplex digital ELISA assay that could be used to detect pancreatic cancer using biomarkers at its early stages. Currently, pancreatic ductal adenocarcinoma, or PDAC for short, is the third leading cause of cancer-related death in the United States, with the highest mortality rate of all major types of cancer. The PDAC tumor, shown here, can be derived from the intraductal papillary mucinous neoplasm, or IPMN, for short, over time. And this is the IPMN tumor. There have already been advances in the detection of IPMNs in early stages of pancreatic cancer. However, the techniques used are invasive. My project uses the sandwich ELISA assay technique, shown here, to detect specific biomarkers in circulating extracellular vesicles, or EVs for short, that can predict the presence of invasive cancer within IPMNs, and these EVs can be derived from scant plasma samples, thereby making this technique quick and less invasive. So you can see the plasma sample and you can derive these very small quantities of EVs. The hallmark of developing this multiplex digital ELISA assay for cancer biomarker detection using EVs is the in-house engineering of magnetofluorescent nanoparticles corresponding to specific biomarkers, which are loaded into an array, which we designed prior to actually running the ELISA assay. So here you can see the different magnetofluorescent beads. Each color corresponds to a different biomarker, and then you can see that they're organized in this array pattern. The array enables the high throughput analysis of the EV biomarkers using sophisticated microscopy and imaging techniques. Ultimately, this project has an enduring impact on the field of cancer nanomedicine, as it exemplifies how nanoparticle synthesis can drive the creation of diagnostic tools for various health conditions, particularly cancer, that are quick, easy, and non-invasive. This CaNCURE co-op experience definitely exposed me to cancer research for the first time, and it influenced cancer research to essentially serve as a vehicle to explore or develop my research interests as I became interested in bioengineering, immunology, and assay optimization research due to the novel techniques I learned to use for my project. Overall, I believe that my co-op has strengthened my interest in cancer, as there is so much room for innovation with regards to clinical medicine as well as medical technology and cancer research. Some of the new skills I learned as a part of my co-op include flow cytometry, ImageJ analysis, and various other image analysis techniques, the actual ELISA assay, as well as the microBCA protein quantification assay. In the future, I'd like to learn more advanced imaging or microscopy techniques, perhaps of, let's say, live cells. I'd also like to learn the organic synthesis of certain biomolecules that are used in nanomedicine research, EV purification techniques, as well as cell culture. The most valuable experience that I would take away from my co-op would be learning how a research project is developed from start to finish when it comes to experimental design, and then finally communicating those results effectively through figures in a paper. The type of project I embarked on as a part of this co-op definitely inspires me to consider having my next co-op focus on nanomedicine research that targets perhaps a different health condition, or even has different goals, such as, let's say, drug delivery or imaging optimization in a different type of biological sample. I definitely want to stay in the translational research space. I envision such co-op or internship experiences in nanomedicine helping me to forge a career as a physician scientist.